Alright, this is a problem involving a normal distribution, but it's a little bit unorthodox in the way it's stated. Let x be a normally distributed random variable with mean 100 but an unknown standard deviation sigma. Suppose that you are told that the probability that x is between 95 and 105 is 0.8124. Find the value of sigma. Okay, so let's start drawing the picture for this. So bell curve here. So 95 is over here, and 105 is over here, and we're told that the area between them is 0.8124. And what's very important for this particular problem is that 100, of course, is the midpoint of 95 and 105, so that's the midpoint there. So basically we need to find 105 is going to be a certain percentile of the distribution. We just need to figure out which percentile that is. So we need to find the area to the left of the mark that I'm putting here in blue. If I can find the area to the left of this blue mark at 105. Okay, so to do that, let's pull up our calculator. So what I need to have is 0.8124, so the area in the tails combined will be equal to 0.1876. And so dividing by 2, the area in any one tail is 0.0938. So I'll mark that in the picture. This area in here is 0.0938. And so the total area to the left of 105 will be equal to 0.0938 plus 0.8124. So that's equal to 0.9062. So the combined area is 0.9062. Combining the middle as well as the left tail. So 105 will be the 90.62 percentile of the distribution. So using the command invnorm of 0.9062, that tells me the z-coordinate in standard units of 105. So that's equal to 1.3177. So if I mark the z-axis down here, that's 0, and this number is 1.3177. So now we have to figure out the value of sigma. Now intuitively what happens is that 105 is 1.3177 standard deviations above average, and so I can solve for sigma that way. Just simply using the formula, we know that x is equal to mu plus sigma z. That's my conversion for standard units. In this case, we have 105 is equal to 100 plus sigma times z, which we have solved to be equal to 1.3177. And so therefore we can solve for sigma to be equal to 5 over 1.3177. And so using the calculator, 5 divided by the standard deviation, or 5 divided by the z value we had, gives us the size of the standard deviation of 3.7945. And so here we're kind of working backwards. An area was given, and we are figuring out one of the parameters of the normal distribution.